Morning students. Today we learn how to find the minimal set of functional dependencies or irreducible set of functional dependencies. Let's consider a relation R A B C D E with the set of functional dependencies F A arrow D B C arrow A D C arrow B E arrow A E arrow D. To find the minimal set of functional dependency, at first step 1, at first we decompose all the functional dependencies in such a way so that all the functional dependency right hand side will be a single attribute. That means for this case A arrow D, the right hand side of this functional dependency is single attribute, so no problem. Now for BC arrow AD, the right hand side consists of more than one attributes. So we just decompose this by BC arrow A and BC arrow D. Now for the remaining functional dependencies C arrow B, the right hand side is single attributes, no problem. E arrow A is also the single attributes in the right hand side, no problem. And E arrow D is also the single attributes in the right hand side. So our set of functional dependency becomes A arrow D, BC arrow A, BC arrow D, C arrow B, E arrow A, E arrow D. So after step 1 we get the set of functional dependency F as this. Now step 2. In steps 2, remove the extraneous attributes. Extraneous attributes mean in a functional dependency the attributes is extra. That means if we remove that attributes from that functional dependency, the closure of the functional dependency does not change. So find the extraneous attributes from the functional dependency. If the left hand side consists more than one attribute, then there will be some possible of extraneous attributes. Now in this set of functional dependencies A arrow D, the left hand side is the single attribute, so there will be no any extraneous attributes. Now for this BC arrow A and BC arrow D, there will be the left hand side is the more than two attributes, so we can find the extraneous attributes if there and we remove it, and the rest of the functional dependency C arrow B, E arrow A and E arrow D are in the left hand side is single attribute, so there will be no any extraneous attributes. Now we consider the functional dependency BC arrow A. Now for BC arrow A, at first we find the closure of B and the closure of C. B closure only we get B. Now for C closure, initially C closure will be C, then C comma B as C tends to B, then BC, so this will be C comma B comma A as BC tends to A, and C comma B comma A comma D as BC tends to D. Since C closure contain the right hand side, contain the attributes B, that's why B is extraneous in the functional dependency BC arrow A, and we discard the extraneous attributes. Therefore, BC arrow A implies C arrow A. Now again we check for the functional dependency BC arrow D. Now again we find the B closure and the C closure. Again B closure only consists of B, C closure consists of C, B, A, D as earlier. Again C closure contain the attributes B, therefore B is extraneous again. Extraneous attributes in the functional dependency BC arrow D. So we remove B and BC arrow D implies C arrow D. So in these steps we remove all the extraneous attributes from the set of functional dependency, and our functional dependency becomes A arrow D, C arrow A, C arrow D, C arrow B, E arrow A, and E arrow D. Now in step 3, we remove the redundant functional dependency. Remove the redundant functional dependency. In step 2, we get the functional dependency A arrow D, C arrow A, C arrow D, C arrow B, E arrow A, and E arrow D. We check for every functional dependency whether this functional dependency is redundant or not. So we start from the functional dependency A arrow D. Whenever we check the functional dependency A arrow D, we just exclude that functional dependency from the set of functional dependency and find the closure of the left hand side attributes, that is A in this case. Now for this A closure will be only A. Since A closure does not contain the right hand side, attributes of the functional dependency A arrow D, therefore A arrow D is essential. Now we check for the C arrow A. For the functional dependency C arrow A, again we calculate the closure of C, excluding the functional dependency C arrow A in the set of functional dependency. Now C A closure will be C initially, then C D as C arrow D, then C D B as C arrow B. Again C closure does not contain the right hand side attributes of the functional dependency C arrow A. Therefore, C arrow A is essential. Now, we go for the functional dependency C arrow D. Now, C arrow D, again we find the closure of C. Initially, C will be C, then then C A as C tends to A, then C A B as C tends to B, and C A B D as A tends to D. Since C closure contains the right hand side attributes of the functional dependency C arrow D, therefore C arrow D is redundant. And discard these things. Now we check for the functional dependency C arrow B. Again we find the closure. C closure will be starting C, then C comma A as C tends to A, C comma A comma D as C tends to D. Since C closure does not contain the right hand side attribute of the functional dependency, C arrow B, therefore C arrow B is essential. Now we check for the functional dependency E arrow A. We find the closure E closure, initially E, then E D as E tends to D. Since E closure does not contain A, therefore E arrow A is required. Now we check for the functional dependency E arrow D. Again we find the E closure, initially E, then EA as E tends to A, and EAD as A tends to D. Therefore, E closure contains the right hand side attributes D. Therefore, E arrow D is redundant and we remove. So our minimal set of functional dependency F becomes A arrow D, C arrow A, C arrow B, and E arrow A. So this will be the set of minimal set of functional dependency. And by this way we can find the minimal set of functional dependency. So again I just repeat the steps to find the minimal set of functional dependency. Step 1, every right hand side of functional dependency should be single attribute. Step 2, remove extraneous attribute from the left hand side of any functional dependency. And step 3, remove redundant functional dependency from the set of functional dependency. So again I just repeat the steps once again. At first we decomposed all the functional dependency whose right hand side consists of more than one attributes. In this case BC arrow AD, we decomposed it as a BC arrow A and BC arrow D. Next step, we remove all the extraneous attributes from the functional dependency which consists more than one attribute in the left hand side. In this case BC arrow A and BC arrow D, this functional dependency consists more than one attributes in the left hand side, and we find the closure of the attributes present in the left hand side separately. For BC arrow A we find the B closure and the C closure. Since C closure consists the attributes B, so in this case B is the extraneous attributes and we just discard the extraneous attributes from the functional dependency BC arrow A and it becomes C arrow A. Similarly for the BC arrow D we find that B is the extraneous attributes and we just discard that extraneous attributes and it becomes C arrow D. After second step, our set of functional dependency will be A arrow D, C arrow A, C arrow D, C arrow B, E arrow A and E arrow D. Now steps 3 we discard all the redundant functional dependency. For discarding the redundant functional dependency, we consider one functional dependency at a time and we just find the closure of the left hand side of the attributes of that functional dependency, exclude that functional dependency, and in this case we calculate for the A arrow D, we calculate the closure of A and we get A closure is A and does not contain the right hand side attributes D, so A arrow D is required. Now for the functional dependency C arrow A, we calculate the closure of C excluding the functional dependency C arrow A, and we get that C D B, and which does not contain the right hand side attribute C arrow A. So C arrow A is essential. Now for C arrow D, we calculate the closure of C, and in this case we get that C closure consists of the right hand side attributes D of the functional dependency C arrow D. So C arrow D is the redundant, and we discard this functional dependency from the set. Now for C arrow B, again we calculate the C closure, and in this C closure the B is not there, so C arrow B is essential. Now for E arrow A, we find the E closure, and E closure consists of E and D that does not consist the right hand side attributes of the functional dependency E arrow A, that is A. So E arrow A is required. Now for E arrow D, again we find the E closure, and we see that E closure consists of the element D, and hence E arrow D is redundant, and we discard this, and the set of minimal functional dependency becomes, for this example, A arrow D, C arrow A, C arrow B, and E arrow A. So thank you for now.